Welcome class. Today we have indefinite integral, and we already released video on the introduction to calculus, which is differentiation. Endeavor to watch it. But what we are doing today in this indefinite integral, it just simply means the revise of differentiation. For example, under integral, if I give you the integral of, when you see this symbol, it's a symbol of what? Integration. So if I give you an integral of Sn dx, so what you basically do is you add x, you add 1 to the power, and then divide everything by the whole n plus 1. You can see from the formula, and you always put a constant word c. So, for example, look at what I'm saying. If I give you the integral of s raised to the power of 3 dx, so it's simply what? X raised to the power of 3, you add 1 to the power, and then you divide everything by this plus this should give you what? 4. So this is what? You divide everything by the power, which is 3 plus 1. So this will give you x raised to the power of 4 divided by what? 4 plus what? C. And so if I give you the integral of s raised to the power of 5 dx, your answer should be what? S raised to the power of 5 plus 1 all over what? 5 plus 1, which is the same thing as s raised to the power of 6 divided by what? 6 plus what? C. Please note that we always, under this indefinite integral, the constant c is always included. You have to include a constant. So if I give you the antiderivative of, let me say, s raised to the power of 7 dx, so it's what? Is x raised to the power of 8 divided by what? 8 plus what? C. So this is basically what the formula is saying, and this is basically what we'll be getting under this word indefinite integral. Are you with me? Good. Now, what if I give you an integral of, for example, an integral of e dx, and you should solve this integral of e dx. So the answer, whenever you see an e dx, the answer is always that e. So, and when you differentiate this dx, what you get is ez plus what? C. So if I give you an integral of, for example, integral of 8x raised to the power of 3 dx, so what is going to give you is what? 8x. So this is 3 plus what? 1. So divided by 3 plus 1 is what? 4, right? Good. Plus what? Your constant c. So this is what? 8x raised to the power of 4 divided by 4 plus what? C. So what if you have an integral of what? 5x raised to the power of 6 dx. So the answer to this antiderivative is what? 5x. We add 1 to the power, so this is s raised to the power of 7 divided by what? The power, which is what? 7. Are you with me? So you put what? Plus c. So you could see that all these things are what? They are not that difficult. But what if you have, like example, an integral of 7x dx? So this will give you what? 7x squared. We add 1 here, and then divided by 2 plus what? C. What if you have an integral of 3x dx? So what are you going to get? What you're going to get is what? 3x what? Squared divided by 2 plus what? C. But what if we have a polynomial? What if I have a polynomial and I give you this is x squared minus 5x plus what? C. 6 dx. So the antiderivative is what? What you're actually going to do is, this is integration involving what? Polynomials. So what we will do here is that you integrate this keep, you integrate this keep, you integrate this keep, and you put your constant c. So here is raised to the power of 2, you add 1, so it will give you what? X raised to the power of 3 divided by 3 minus, here is 1 plus 1. So you have what? 5x raised to the power of 2 divided by what? 2. So this, whenever you differentiate a constant, what you are going to get is plus 6x. I'm going to explain it very well for you. Whenever you differentiate a constant, what you are going to get is 6x. So here, that is the good. So what you're going to get is this. Some people may ask me, so why is it differentiated? Like I said, this is a constant because it doesn't have any alphabetical order, right, attached to it. So for example, how I got this 6s is, if I give you, for example, integration, you should integrate what? For example, 6 dx. Now, for you to integrate this, it's very simple. We can rewrite this as what? Integral of what? 6s raised to the power of 0, 1 dx. It's still the same thing. In law of indices, anything raised to the power of 0 is what? 1. So what I just basically did was I just rewrote it using what? Law of what? Indices. So this is equal to this. So once you have this, so you have an integral of 6x raised to the power of 0, 1 dx. So remember, for we to find the antiderivative of this, we have to add what? 1 to the power. And we divide everything by what? The total power of the what? The total power. So this is what? So this will give you what? 6x 0 plus what? 1. So divided by what? Anything raised to this plus 0 plus 1 should give you what? 1. So have you seen it? So this is how I got what? 6x divided by 1, which is what? 6x. So that's how we got this 6x. So what next, if I give you, for example, the integral of what? 5x dx, your answer should be, if I give you integral of 5 dx, your answer should be what? 5x. Are you with me? Good. Now let's proceed. What if you have another? So under this number 12, what if you have an integral, a polynomial of 4x cubed plus 8x squared minus 9 dx. So this is a polynomial. As usual, the antiderivative will be what? 4x. We add 1 here. So here 4x raised to the power of 4 divided by what? 4. Plus what? You add 1 here. This is 8x raised to the power of 3 divided by what? 3. Minus, remember, the antiderivative of what? 9, which is a constant, will give you what? So this will give you 9x, right? Good. So you can see that we can divide some things. 4 will go into here. So basically you have 4x raised to the power of 4 plus 8 all over 3x cubed minus 9x plus what? C. Under indefinite integral, if you are solving and you stop here without putting your constant, the answer is 0. You must have to what? Include your constant. Always remember that, please. Under indefinite integral, because when we reach definite integral, we don't need this constant because we'll be getting a what? A whole number on it. Now let's continue. What if you have an antiderivative of root of what? X dx. Now you know that this is the same thing as what? Root of what? The integral of x, which is 1 all over 2 dx. Now what we are going to do is what? We have to add 1 to the power, is it not? Yes. So what I normally do is I like bringing the power here. This is 1 all over 2. So I'm going to add plus 1, right? Good. Now you can see that this thing we can solve it using what? LCM, right? But you know that there are 2 ways for you to do this. Instead of you take the LCM and say the LCM is 2, so this into this is 1, this into this will give you what? 2. So you have what? 3 all over 2. Or you write 1 all over 2 plus you already seen this 1 all over 2, so we don't have anything, we only have plus 1. But do you know that 1 all over 2 plus 2 all over 2 is the same thing? Yes, because 2 divided by 2 still give you what? 1. So whenever you have the same denominator, all you need to do is what? Just add the power. So this plus this should give you what? 3 all over 2. Right? Good. Now, when we add 1 to the power, what we got is what? 3 all over 2. That means this has already changed to what? S into what? 3 all over 2 divided by what? 3 all over 2 plus what? C. Something can still be done. Using law of indices, you can see that this, of course, is going to come up, right? So we have what? 2x 3 all over 2 divided by what? 3 plus C. This is pure law of indices. Right? Good. Now, let's proceed to example number 14. So, like I said, from law of indices, that is how we arrive at our answer. But in case you are having a confusion, this is 3 all over 2 divided by what? 3 all over 2. So basically what I just did is what? I inverted it. This is the same thing as s raised to the power of 3 all over 2, right? So times this will come up. So you have what? 2 all over 1, while this one remains. Are you with me? So that's why I got this answer, which is 2x 3 all over 2 divided by 3 plus what? C. Now, what if you have an integral of 3 cube root of 3x raised to the power of 4 dx? I want you to know something. If I give you from this first example, remember that root is 1 all over 2, right? Good. That means that cube root is what? 1 all over what? 3. Are you with me? Good. So basically what we are doing here is you have x raised to the power of 4. So open bracket and close. So you have what? 1 all over 3 dx. Are you getting me? It's the same thing I did here. So you can see that 4 times this will give you 4, and then this one will not give you. So this can be written as what? Integral of what? S raised to the power of what? 4 divided by 3 what? Dx. So once you reach here, life is very what? Easier. So the way we normally used to do it is what? Bring it out. 4 divided by 3 plus what? 1. And you know that since we have 3 here, I can just say 4 divided by 3 plus what? 3 divided by 3, because I want the denominator to be the same. 3 divided by 3 will still give you that one we are adding. So this automatically will give you what? 7 all over 3. If you don't understand this, you can still do the normal procedure. This plus 1. So this is the LCM here is 3. This will go into this. So you have 4 plus 3, which is what? 7 all over 3. So once we have 7 all over 3, insert it here. So this will change to what? This will change to what? X into what? 7 all over 3 divided by 7 all over what? 3 plus C. We can apply the law of indices here. This will come up here. So you have S into what? 7 all over 3 divided by 7 times what? This will invert. Are you with me? So you have what? Times 3. So here is what? 3x 7 all over 3 divided by what? 7 plus what? C. And that is the answer to this. Are you with me, please? Good. So this is the answer, but something can still be done if you want to. That is, if you know your law of indices very well. What can still be done? I can simply extract this 3 all over 7 here. So I have 3 all over 7. Then you have, here is times s raised to the power of 7 all over what? 3. Remember from above that this can be written as what? 3 all over 7 times, let me write it, dot x into what? So here you have root of 7, right? I can put everything and say 1 all over 3, because this time this will give you the same value, right? I just separated it, right? Good. But do you know that from here we say x raised to the power of 1 all over 3 is the same thing as what? Cube root of x. S raised to the power of 1 all over 2 is what? Square root of what? Is what? Square root of what? X. So from here, can you see that we can still do something if you want to do something? Yes, of course. Here can simply be what? 3 all over 7 dot, which is times cube root of what? Cube root of s raised to the power of 7 plus what? C. Still the same answer. Still the same answer. So in this integral, we have an integral of what? minus 1 raised to the power of 2. The best way for you to do this is what? You work on the bracket. So this is 3x minus 1, and open bracket 3x minus 1, because we have square, right? Good. Dx, right? Yes, dx. Now the next thing you need to do is open the bracket. So 3x times 3x will give you what? 9x squared. This times this will give you minus 3x. This time this will give you minus 3x. Minus 1 times minus 1 will give you plus 1, right? So collect like times, we have 9x squared minus 6x plus 1, right? Good. You have succeeded in turning everything to what? Polynomial. So this is now a polynomial what? Deep integration. So all you need to do right now is what? Integrate. So this is, add 1 here, you have 9x raised to the power of 3 divided by 3, minus, add 1 here, you have square divided by 2, plus what? This is a constant. Whenever you what? Integrate it, you will get what? X, right? Because it's 1x, so 1 times x will give you x. Good. Plus what? C. You can see that something can still go 1 here, 1 into here, 3. 2 here, 1. 2 into here, 3. So you can arrange our answer to be what? 3x cubed minus 6 minus 3x squared plus x plus what? C. And that is the word, the answer. Please do not forget your word. Do not forget your constant always. Now, example number 16. Under example number 16, you can see we have the same thing. What are you going to do? Open the whole bracket up. This times this will give you a 2x raised to the power of 2. This times this will give you minus 4x. This times this will give you minus x plus what? 2, right? Good. So collect like terms, we have 2x squared minus what? 5x. Minus 4x minus x is minus 5x plus what? 2, right? Good. Now you can what? You can integrate. So this is polynomial. So this is what? 2x raised to the power of 3 divided by 3 minus 5x raised to the power of 2 divided by 2 plus what? 2x, right? So nothing can divide. You add your constant c, and that is the answer. Are you with me, guys? Good. What if, on example number 17, what if you have the integral of x raised to the power of 4 plus 6x raised to the power of 3 divided by x dx? How are you going to solve this problem? It's very simple. Whenever you have a single denominator and you have it arranged like this, it's very simple. All you have to do is what? You divide out. You can see that s can go into this place, s can go into this place, right? So this is the same thing as what? X raised to the power of 4 divided by s plus 6 raised to the power of 3 divided by what? S what? Dx. So s will go into this one, so you have what? You have s raised to the power of 3. So this will go into this, you still have what? 2x, right? So this will now turn to what? X raised to the power of 3 plus x raised to the power of what? 2 dx, and our integral value is still here. So all you need to do right now is what? Integrate, right? Good. So whenever if you integrate, you add 1 here, you have x raised to the power of 4 divided by 4 plus 6x raised to the power of what? 3 divided by 3 plus 6. Now, 3 into here 1, 3 into 6 is give you what? 2. So this is what? S raised to the power of 4 divided by 4 plus 2x raised to the power of 3. Right? Then you have plus c. And that is the what? The answer. Come to example number 18. Example number 18. What if you have an integral of 1 all over what? S cubed dx. When you have something like this is a law of indices. Remember, in law of indices, 1 all over s is the same thing as s raised to the power of minus 1, right? Good, the inverse law. Now, if you apply this thing here, this thing is the same thing as integral of what? X raised to the power of minus 3 what? Dx. From here, you can see that life is already easy. You can pause the video video and what? Finish it up. So this will be what? S raised to the power of what? Minus 3 plus 2 dx. So minus 3 plus what? 1. So this will give you what? S raised to the power of minus 2 plus c. Right? Which I've already integrated it. So this will give you S raised to the power of minus 2 plus c. But if you want, you can leave your answer like this. If you want, you can still keep it that 1 over what? S squared plus c. Are you with me? Good. Now, after this, wait, I think I made a mistake here. This is minus 3 plus, this is minus 3 plus 1. So this will give me minus 2. So minus 2, please be careful. I made a mistake. A very huge one. I made a mistake. So here is minus 2. Yes, you got it correctly. I made a mistake here. This is minus 2 divided by what? Minus 2. I forgot to divide it, right? So you have plus c. Now, the next thing I want to do is arrange my answer. So remember, this can come down. And whenever it comes down, so you have minus 1 all over 2s squared. Because I want to bring this one down from our law of indices here. Right? So plus c. And that is the answer. Please do not make the mistake I made. After plusing 1, I forgot to what? Divide it by what? The power. Good. What about if you have a question? Example what? Number 19. You have something like this. You have an integral of 5 all over s raised to the power of 4 dx. So, what would this give you? You can see that we can still apply that inverse law. So, this is the same thing as 5s raised to the power of minus 4 what? Dx. Right? Good. Now, the next thing is I'm going to add what? 1 to the what? To the power. So you have 5x minus 4 plus 1. Right? So this will give me what? 5x minus 4 plus 1 will give you minus 3. Divided by what? Minus 3 plus c. But something can still be done here. I want to bring this down. So this will give me what? Minus 5 all over 3s raised to the power of 3 plus c. Are you seeing how easy this can be? It's too easy, right? Good. Example number 20. Example number 20. What if you have an integral of this is wonderful. 1 all over s dx. Now under this we have a rule. This is a powerful rule under integration. Now if we follow our power rule, we have s raised to the power of minus 1 ds, right? Using law of indices. So I add my what? So I want to integrate this value. So it's going to give me x minus 1 plus 1. So this will give me what? X raised to the power of what? 0 divided by 0. And 0 divided by 0 is what? This will give me 1 all over 0. And this is undefined. So I don't want this. I don't want this. So under integration, whenever you have, please pay attention. This is a powerful rule. Whenever you have 1 all over x, the integral value is just, the answer is simply ln x plus c. How sweet can this be? How sweet can this be? So basically, whenever you have, let me give you a simple how to. Whenever you have something like this, and like I said, this is the standard rule for it. But over here, the way I do it is, immediately you give me an integral, I have 1 and I have x in it. So what I basically do is, I go to my denominator and I differentiate it. And if I differentiate my denominator, it gives me the value of my numerator. I will just write ln of what? The denominator. If you differentiate x, what you are going to get is what? 1. We have already done differentiation. If you differentiate x, what you're going to get is what? 1. Because this will now be x, this power of 1. This, you have 1 minus 1. So you have x, this power of what? 0. So this will give you 1. Please, if you don't know differentiation, the video is at the playlist. So whenever you have 1 over s, what I'm going to get is ln s. Example number 21. We are coming to the interesting part of all this. S minus 3 dx. This rule and this rule are the same, please. So if you differentiate s, you get 1. If you differentiate a constant under differentiation, what you are going to get is 0. So that means the answer is simply what? Ln of what? X minus 3 plus c. Example number 22. If you don't know more on differentiation, we have a video, introduction to differentiation. Introduction to differentiation is under our playlist. Now, what if I have 1 all over s plus 4 dx? This and this, they are all the same. 1 give me 1 here. So my answer is what? Ln of what? X plus 4. S plus 4 plus what? C. Good. Example number 23. Example number 23. What if I have the integral of 5 all over s minus 2 dx? Say, master, there is no 1 here. Of course, there is 1. Why? I can remove this 5 outside. So if I remove this 5, I have 5 integral of what? 1 all over x minus 2 dx. Please be wise in this, because they are still the same thing. So you can see that this will give me, this will now give me what? My 5 that is already outside. Ln of what? X minus 2 dx. Example number 24. Please be noting this rule is too powerful. Example number 24. What if you have E, another powerful rule? E 4x dx. What are you going to do if you have this value? So, under example number 24, what you are actually going to do is what? All you have to do is just bring back this 4, because this will still give you, if you integrate this, you still get 4x. So you divide everything by the what? The constant attached to the 4, the x, which is the coefficient of x. So which is what? 4 plus c. Example number 25. An integral of e 7x dx is equal to what? E 7x, still the same, divided by the coefficient of x, which is 7 plus what? C. Good. What if, example number 26, what if I now change it, you have an integral, here is 8. You have 8e 2x dx. So you bring this outside, this will give you 8. An integral of e 2x dx. And you know that this will give you 8, this will give you the same thing, 2x, right? You divide everything by 2 plus c. So this will give you 8e 2x divided by 2 plus c. But 2 go into here, this will give you 4. So you have 4e 2x plus what? C. And that is the answer. Are you with me? Good. Example number 27. What if number 28? So you have 2 this. What's the answer? You bring out this. So you integrate this. So you have 3x divided by 3 plus what? C. Right? This will go into this. So you have 4. Here 3x plus what? C. Good. Now, welcome to integration involving 3 functions. Integration involving 3 functions. That is what we are going to into next. Now, I want you to know that if I give you example number 29, if you have cos x dx, you have to know this. Whenever you integrate cos, what your answer will be sine. So your answer here should be what? Sine x plus what? C. Good. What if you integrate number 30? If you integrate sine x dx, your answer will be what? Whenever you integrate sine, your answer is equal to minus cos x plus what? C. Good. Number 31. What if I give you something like this, cos 3x dx? You already know that whenever you integrate cos, what you're going to get is what? Sine. So all you have to do is sine 3x, you divide it by the what? The coefficient of 3 attached to the sine. So this will give me what? Sine of 3x divided by what? 3 plus what? C. What if you have a cos of what? Cos 7x dx. The integral of cos, what is it going to give you? Please, if you differentiate cos, what are you going to get? You get sine, right? So you have sine 7x divided by the quotient of x plus what? C. 33. What if you have the integral of 14 sine of 2x dx? So what are you going to? First, you have to remove the constant. So whenever you remove the constant, what are you going to do next? Whenever you differentiate sine, what you will get is minus cos, right? So first, I'm going to remove my constant and write integral of what? 2x dx. So whenever you integrate sine, what you're going to get is minus cos. So you have 14 minus cos 2x divided by what? 2, right? Plus c. Now, 2 will go into here. 2 will go into here to give you 7. So my answer should be minus 7 cos of 2x plus what? C. Good. Number 33. This is number 34. Number 34 is integral of 6 sine of 3x dx. What are you going to do? Whenever you differentiate sine, you get minus cos. So this will give me what? 6. By bringing the constant outside, we differentiate this, we get minus cos 3x divided by what? 3 plus c. This will go into this will go into this 2. So what are you going to have? What you're going to get is what? Minus 2 cos of 3x plus c. And that is the answer. So number 36. Number 36. Okay, this is 35. This is not 4. This is 35. What if I give you the integral of what? Sec square x dx. So the integral of sec square x dx will give you what? Tan x plus c. Whenever you integrate sec square x, what you're going to get is what? Tan x. And you put your constant c. Note this, it's very important, please. Number 36. What if I give you 8 sec square, we have 4x dx. So the next first thing is to bring out the 8. Whenever you differentiate this, what are you going to get? Tan. But you have 4x, so we have 8 tan of 4x divided by 4 plus what? C. Remember, why we do this one, if you differentiate, we only have the coefficient of what? 1. And whenever you divide by 1, you still get this. So here, the coefficient of s here is 4. That's why I'm dividing by 4. So here is 1. Here is what? 2. So you have 2 tan 4x plus what? C. Example number 37. Example number 37. Under trig function. So on number 37, what if you integrate sec x and tan x dx? So the integral of sec x tan x, what is going to give you is what? Sec x, sec of what? Sec x plus c. Please note all these things I'm what? Writing. Number 39, 38. What if you have 2 12 sec 3x than 3x dx. Whenever you see this thing, you think it's very difficult. It's too simple. So whenever you see something like this, what are you going to do? Bring out your 12. If you bring out your 12 first, the constant, the integration of sec x tan x will give you what? Sec x. Can you see how simple this is? It's too simple. So all you have to do, this is just what? Sec of what? 3x divided by what? 3 plus c. But 1 will go into here, 1 will go into here, 4. So you have 4 sec what? 3s plus what? C. Are you with me? Good. So, class, if you keep on seeing all these things, you see how easy and simpler this is. So please, under trig function, make sure that you note the integral value and the answer of all these things. You can imagine if you see this in an exam, you think it's a very, very difficult something, but it's just one line. This is the end of what? Indefinite integral. Thank you very much, class.